Okay, students, welcome back. This is going to be the second part, and we're probably going to take maybe 1 or 2 more days to finish off systems of linear equations. I do want to tell you guys again what had happened last class, which was last week. What is a system? You basically have 2 or more equations with 2 or more variables. Okay, so the first one was solve the system by graphing. We actually did some graphing the 2 lines, see where they intersect. The new part was sometimes your lines are not in slope-intercept form. If they are in standard form, we have to do some sort of type of manipulation to solve for y and see where they intersect. If the lines intersect, then we state the intersection point, so -3, 2. But it's not always going to be the case. Sometimes your lines are parallel. If the lines are parallel, there's no intersection, we put no solution. And then on number 7, if we happen to have 2 of the same lines or more, then your solution will be infinite solutions. Okay, so this is where we left off. Let's now go to number 20. There is another way to solve for a system without having to graph it. You don't have to flip your paper, just make sure you're at number 20. I'm going to flip my paper back. One downfall of graphing is if your line is a little bit crooked, even if it's 1 millimeter crooked, your intersection point might be a little bit off, okay? So that's going to be one downfall of us solving by graphing. Sometimes doing it algebraically might be a little bit more accurate. So to solve by substitution, another method, how do we do this? Let me just write first. Today we're going to have 2 mental health breaks. The first one 2 minutes, and then the last one 1 minute. Okay. So for the first mental health break 2 minutes, we need to use the bathroom. Go ahead and do so. Okay, going back to the work. How do we do this? Well, substitute means to plug in. So we are going to be plugging in some things. We plug in an expression from the first equation and put that into the second equation. We have 2 big scenarios. So big scenario number 1 and big scenario number 2. And on the second scenario, I'll give you guys 4 different examples of what could happen from your guys' answers. Okay, let's go ahead and start with the scenario, big scenario number 1. Both of your equations are in slope-intercept form, y equals mx plus b. Meaning that if you take a look at the equations, it's y equals, and then y equals. So to solve this, step 1, you are going to set it up like this. Because I have 2 y's that I see, these 2 y's need to be equal to each other, so y is equal to y. Once you have that general setup, oh gosh, you know, sometimes like the autofocus is not. I'm getting dizzy already. Okay. Once you have this set up, then we're going to plug in and substitute for some of the expressions. Your first y is equal to 3x minus 1. So on the left side, I'm going to put 3x minus 1. A4, what do you think we should put here on the right side? Negative 5x plus 23, because that was the second y that was defined for us. Now, I'm always referring back to what we've done the first, second week of school, because now this looks like an equation from the first and second week of school. I'm going to move all the x's on one side. Students, opposite of negative 5x, please. Add. So we're going to plus 5x on both sides. Eight x minus 1 is equal to 23. Next step, please. We're going to add 1 on both sides. And again, if you need to use the barrier, please go ahead and do so. So this goes away. 23 plus 1 is 24. Last step, please. Divide 8 on both sides. Okay. We're actually not going to box this. We're going to like take note of it. Like, okay, I see this part of it here. Okay. We're actually not done. Yes, we solved for x, but we're not totally done. What we also need to get is also the y value as well. And so for your, I guess maybe step number 3, solve for the second variable. The question has always asked, Mr. Lucas, what can I use? So now that you know that x is equal to 3, what I mean by this is you're going to plug it into an equation. Well, which equation do you choose? Do you use the top one? Do you use the bottom? Or does it matter? Or it doesn't matter? It does not matter at all. So actually, if you put 3 on both of them, it should come out to the same answer. Okay? I'm just going to use the top one just because I see that, and I don't know, I get intimidated with the 23 because it looks too big. Okay, so you're going to just pick any equation. I'm just going to pick the top. Actually, for your notes, if you want to pick the bottom, go ahead and do it. We should come out with the same y value. But let's go ahead and plug in the 3 inside here. Y is equal to 3. 3 times 3 minus 1. And then you just got to make sure you do PEMDAS on the right side. 3 times 3 is 9. 9 minus 1 is 8. And then we will take notice of this. So I guess in a sense, maybe there are 4 steps over here. Okay. Your final answer, your solution, since we have an x and y, it needs to be in coordinate form. And so let's go ahead and make those coordinates in parentheses. Students, shall we write 8, 3 or 3, 8?
No, 3, 8.
Y, 3, 8. X, Y. So please be careful with the order. The order does matter. The order of x, y. Students, I want to go to Desmos.com just so that you guys have a visual, because you have the math. Mr. Lucas, what are we solving for? Like, what does this 3, 8 mean? So let's go ahead and actually just plug this in on Desmos.com. Let's plug in the first equation. It was 3x minus 1 plus 1. I forgot. Minus 1? Okay. So they both should be lines. The y-intercept is at negative, 1, and then the slope is 3 over 1. Okay, so it follows that pattern. Let's put the second one over here. Y is equal to negative 5x plus 23, right? Yes, 23. Okay. So I think we'll just have to zoom out a little bit over here, but if we zoom back in and take a look at this point, it's 3, 8. So again, what we're trying to solve for is we're solving for where these two lines intersect. They intersect at 3, 8, but it's just that we don't have to graph them anymore. We can use a different method called substitution. But this is the visual of what you guys are solving for, just so that you guys can have a picture. Like, okay, this is what we're solving for. These two lines intersect at 3, 8. Any questions on the visual that's attached to the map? Any questions? Okay.